Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry. The course code is 0620. And if you need one-on-one tutoring lessons, you can fill out the Google form that is given in the description. And you can also join my community. It is free to join, with the name of High School Chemistry on school.com, where I offer one-on-one lessons and group lessons as well. So you can attend group lessons, like 4 lessons a month, once a week, and one-on-one lessons according to your preference, but the seats are very limited. And you can join that community for free, and on that community I also offer one free lesson per month, right? You can ask me questions, you can participate in the discussion forums. If you have any question related to chemistry, you can post, you can interact with other students, so all that is absolutely free. And I'll hope to see you there soon. You can also like and subscribe and share. You can share this playlist with your friends as well. So now this is the practice session of for 6.2 rate of reaction, and this topic is considered to be a difficult topic. So I've included many questions, as you can see here, and I will try my best to answer most of them. If there was a repetition, then we may skip a few, but I'll try my best to explain this topic 100%, right? So before this lecture, we have covered the theoretical part of rate of reaction, for both core and extended students. So if you don't have the foundation for this, so I would suggest that you should go back and watch rate of reaction part 1, rate of reaction part 2, and then come back and then try to solve these questions, right? So the first question is, samarium is a metal. Large pieces of samarium react with cool water to produce hydrogen gas, blah, blah, blah. Complete figure 5.1 by drawing the apparatus to show how the volume of hydrogen gas is measured during this reaction. So we understand that hydrogen, the volume of a gas is measured by a special apparatus which is called a gas range. So the first thing that you're going to do is that you're going to seal this conical flask, so that the gas that is being produced, it should only go through to this gas range, right? So we put this glass tube, which will further be connected to the gas range, right? So this is how a gas range looks like. Yeah, and here you can draw these graduated yeah, lines like this, so that uh, you know depicting that this is it can be used to measure volume, right? Yeah. So this is the gas syringe, right? And remember that this conical flask, it must be sealed. So this is going to give you 2 marks, right? So I hope this is clear. And now we move on to the next part. And I think you can extend this into the liquid, right? Yeah, it should be dipping into water drawn. Okay, so now we move on to the next part, and that is, the experiment is repeated using hot water instead of cold water. All other conditions stay the same. Describe how the rate of reaction changes when hot water is used. So here you need to remember the relationship of temperature on the temperature change on the rate of reaction. So we know that when temperature is increased, the rate of the reaction, it increases, right? So you will just say it increases. That's it, right? So this question is from paper 3, and And the experiment is repeated using powdered samarium instead of large pieces. So here now we are trying to assess the effect of surface area. So because powdered substances, they have a greater surface area as compared to the large pieces of the same mass. So all other conditions stay the same. Describe how the rate of reaction changes when powdered samarium is used. So again, it will increase because surface area is being increased, right? So you can say that it increases. So next question is a student investigates the reaction of iron powder with dilute hydrochloric acid at 220 degrees Celsius. The hydrochloric acid is in excess. So figure 8.1 shows the volume of hydrogen gas released as the reaction proceeds. So volume of a gas, um yeah, okay, this is the first question. Deduce the volume of a gas released after 2 minutes, right? So deduce the volume of hydrogen gas released after 2 minutes. So here, this is the 2 minute mark. So, oops. So where were we? Yeah. So here, uh, I draw a line like this, right? And I go all the way to this, right, this side. So this is the volume of hydrogen gas at 2 minutes, right? Yeah, reduce the volume of gas released after 2 minutes. So this is 27 centimeters cubed. So the answer is 27 centimeters cubed. And the student repeats the experiment using dilute hydrochloric acid of a higher concentration. All other conditions stay the same. Draw a line on the grid in figure 8.1 to predict how the volume of hydrogen gas changes when dilute hydrochloric acid or of a higher concentration is used, right? So remember that, that the final volume of the hydrogen gas will remain the same, and um, yeah, but the curve must be steeper, right? So we can draw it like this, and it should start from 0, right, like this. So you can draw it more neatly, but these 2 points, they must match, right? Yeah. So now we move on to the next part. The student repeats the experiment with large pieces of iron. All other conditions stay the same. Describe how the rate of reaction differs when large pieces of iron are used. So the rate decreases, right? Because the surface area is being decreased. So we say that it slows down, or you can say that it decreases. So rate decreases. So I hope this is clear. And now we take a look at the next part. The student repeats the experiment with iron powder at a temperature of 15 degrees Celsius. And all other conditions stay the same. Describe how the rate of reaction differs when temperature of 15 degrees is used. Uh, yeah. So let me see that what is the temperature when. Yeah. So here they have like initially the temperature was 20 degrees Celsius, right? And now they have decreased the temperature. So describe how the rate of this reaction differs of 15, when the temperature of 15 degrees Celsius is used. So the rate will decrease because we are decreasing temperature, right? The student repeats the experiment with iron powder at temperature of 15 degrees Celsius. All other conditions stay the same. They describe how the rate of reaction differs when a temperature of 15 degrees is used. So we are decreasing temperature so that reaction will slow down. And all right, so now we move on to the next one. A student investigates the reaction of small pieces of zinc of the same mass and size with three different concentrations of dilute hydrochloric acid in the presence of a catalyst. So the three concentrations of dilute hydrochloric acid are this, and this. All other conditions stay the same. So table 6.1 shows the time taken for each reaction to finish, right? So here, uh, um, a student investigates the reaction of small pieces of zinc, okay, and table 6.1 shows the time taken to finish. So concentration, yeah. So you can see that if it is taking most time 200 seconds, so it is going to be the least concentrated, right? So it will be 1 mole per dm cubed, right? And now it's 100, so it is the least time. So 100 seconds is the shortest time as compared to the other two readings. So this is going to be the one with the most concentrated, right? So this is going to be 2 mole per dm cubed. And for 150, yeah, so this is the second highest, so it will be the like 1.5 mole, right? So I hope this is clear. Per dm cube. So now we move on to the next part. Complete table 6.1 by writing the concentrations of hydrochloric acid. Yeah, I think, yeah, we did. Yeah, that's why I read the question again. I was looking for a graph or something. So this is what they wanted to do. Yeah, okay, I wanted us to do. So next question, describe the effect of on the time taken for the zinc to finish reacting with 2 moles per dm cube hydrochloric acid with no catalyst present. All other conditions stay the same, right? So yeah, so if, without the catalyst, so it's going to take longer. So you say that it takes a longer time, right? So we know that catalyst speeds up a reaction, but if catalyst is not used, then you see it says that in the presence of a catalyst, so it's going to speed up the reaction. But now in this question they are saying that with no catalyst present, so it will definitely slow down, and it will take longer time. So I hope this is clear. So to summarize the questions that we have attempted, so they were asking us the relationship between temperature change and rate of reaction, powdered, so surface area and the rate of reaction, and here concentration and rate of reaction. So when concentration is increased, so the rate increases, right? This one. And the plot where they asked us to draw this graph. Um yeah, the dilute hydrochloric acid of a higher concentration, so it's going to increase the rate of reaction. And now we move on to the next part. So these questions now, these are from paper 4. So let's take a look at this question. And the first question, it says that the Haber process is used to manufacture ammonia. All right. And this is the chemical equation. The reaction is reversible and the forward reaction is exothermic. We can also see this from the negative value of delta H. We know that if this value is negative, so it's an exothermic reaction. So explain in terms of collision theory why increasing the temperature increases the rate of a reaction, right? So and the question has 3 marks. So you must take a look at the total marks of the question before answering so that you can answer accordingly and you get full marks, right? So we understand from collision theory that as we increase temperature, the kinetic energy of the particles increases, right? So I'm going to write that kinetic energy of the particles increases, and which leads to increased collision frequency, increased collision frequency, right? So what is meant by collision frequency? The number of collisions per second, they will increase. There will be more collisions in a given amount of time as compared to lower kinetic energy, right? So when we increase temperature, so the same amount of particles, they start colliding with each other more, which is called collision frequency. So kinetic energy, when kinetic energy of the particles increases, it leads to increased collision frequency, right? And thus the higher percentage, and like there's another point, when temperature is increased, it increases the number of particles having the activation energy, right? You need to understand that at a given temperature, not all particles of a gas, they have the same amount of energy. So some particles, they have higher kinetic energy than the average, and they possess the activation energy. And when these molecules, so let me draw them in red, when these molecules or these particles, they collide, so reactions take place, right? The black ones with lower activation energy, they will not result in effective collisions. And similarly, when the temperature is increased, so the number of particles having achieved the kinetic energy, the activation energy, it increases, right? So now more particles, they have the activation energy, and there will be more successful collisions. So we need to incorporate this third point as well, which is related to the temperature change. And I'm going to write here that kinetic energy of the particles increases, which leads to the increased collision frequency, and the, you know the uh, you know yeah, the particles, and the particles uh, have more particles, and more particles, and more particles have the activation energy, right? Yeah. So this is going to give us 3 marks, right? So now we move on to the next part. Oxygen is produced by the decomposition of aqueous hydrogen peroxide. So hydrogen peroxide is H2O2. So when manganese 4 oxide is used as a catalyst, so it decomposes into uh, you know uh, water and oxygen, right? So H2O and O2. So the next question, the what is state the meaning of the term catalyst? Yeah, so it is a very simple question. So we understand that catalyst is a substance that increases a chemical reaction, and without getting used up, right? So I'm going to write here that it increases the rate of reaction, increases the rate of reaction, right? And and remains and remains unchanged at the end of the reaction, at the end, right? So again, why am I writing two statements? Because again, this question has 2 marks, right? So just saying that it increases the rate of reaction will only give you 1 mark, and you have to gain another mark. You have to write the another attribute of a chemical, another characteristic of a catalyst, that it remains unchanged at the end, right? So I hope this is clear. Now we move on to the next one. State why the mass of the conical flask and its contents decreases as the time increases. So if we look at the diagram, so let me read this again. A student adds powdered manganese 4 oxide to aqueous hydrogen peroxide in a conical flask as shown in figure 4.1, and the mass of the conical flask and its contents is measured at regular in time intervals. The mass decreases as time increases, right? So if you look at this diagram, so you can see here that it says that it loosely fitting cotton wool plug, right? So it means that the gases that the oxygen gas that is being produced, it can escape, right? Because it clearly says that it's loosely fitting cotton wool plug, right? So it will not be able to prevent the oxygen gas from escaping. So the gas escapes, right? So we answer that oxygen. So that oxygen escapes from the flask. Yeah. So I hope this is clear. Next question. The rate of reaction is highest at the start of the reaction, and the rate decreases eventually and eventually becomes zero. Explain why the rate of reaction is highest at the start of the reaction. So if I draw the concentration versus time graph for reactants and products, and they look something like this. So reactants, at the start of the reaction, their concentration is highest, right? Because and the products, they have concentration of 0. So for example, A and B, they are reacting together, and we are about to start this reaction. So we have a highest concentration of A and B at the start of the reaction. So as the reaction proceeds and the products start to appear, so it is basically this mass that is being changed on this side into this is being converted into these products, right? So because according to the law of conservation of matter or mass, matter can neither be created nor be destroyed, right? So the mass and atoms, they remain the same. I mean, their mass remains the same. They just can get converted into another form, right? So reactants A and B, the graph will look something like this, and for the products C and D, the graph will look something like this. And when this reaction is a straight line, it may mean that equilibrium has been achieved, or all the reactants, they got used up, right? So so now here, so why the rate of the reaction is highest at the start of the reaction? So it is highest, you can see that the curve is steeper here, right? So steeper curve means faster reaction, and here it is becoming less steeper. So you can see that the rate is decreasing as as the reaction progresses. So we can say here that explain why the rate of reaction is highest at the start of the reaction. So it is related to concentration, right? So we have studied that increased concentration results in the higher rate of reaction. So we can see here that concentration of hydrogen peroxide is highest at the start. So concentration of hydrogen peroxide is highest at the start. All right, explain why the rate of reaction eventually becomes zero. Yeah, so you can say that all the hydrogen peroxide is used up, right? So all the hydrogen peroxide is used up. And for a reaction to achieve equilibrium, it must be sealed. It must be a closed system. So all the contents of the reaction, they must remain in the system in which that reaction is taking place, right? So I hope this is clear. And we move on to the next part. So that's why I'm writing all the hydrogen peroxide is used up. So the next question is the experiment is repeated at an increased temperature. All other conditions stay the same. Explain in terms of collision theory. So you can see that this is paper 4, so it demands more explanation and assessing your concept more thoroughly. So explain in terms of collision theory why the rate of reaction is higher at an increased temperature. So 3 marks. So you have to again, write the 3 statements. So again, the kinetic energy of particles increases, and which results in increased collision frequency, right? Between particles, yeah, or increased frequency, yeah, collision frequency, yeah, between particles, and yeah, so the same thing that more particles have the activation energy, right? Or higher fraction of particles. So instead of more, you can say that higher fraction of particles have activation energy. So these are the keywords. Kinetic energy of the particles increases, increased collision frequency, and more particles have the activation energy. So these are going to give you the 3 marks, right? Okay, so the equation for the decomposition of aqueous hydrogen peroxide is shown. Okay, so yeah, I didn't balance this on purpose. Where is it? Yeah, this equation, it is balanced here. So 2 2. So yep. Okay, anyways, it says that oh, okay, this question is not related to rate of reaction. We have already covered it in the titration section or molarity section. So if you haven't watched that video, or go, you can watch that. So we are answering this one. It says that state the effect on the mass of oxygen produced if the mass of powdered manganese 4 oxide catalyst is increased. Okay, so state the effect on the mass of oxygen produced if the mass of the powdered magnesium 4 oxide. Yeah, so mass of the product has nothing to do with the mass of the catalyst, because catalysts, they only speed up chemical reactions. Catalysts, they don't take part in chemical reactions actively, because they get retrieved unchanged at the we can retrieve a catalyst at the end of the reaction unchanged. So there will be no effect. So this is a tricky question. Many students, they get it wrong, wrong. So you have to be very careful. Remember that the mass of a catalyst has nothing to do. It cannot affect the yield of a reaction in any way. Okay, it can produce it more quickly, right? It can only affect the rate of the reaction, but it cannot affect the yield of a reaction. Okay, so F oxygen can also be produced by the decomposition of mercury to oxide. And the only products of this decomposition are mercury and oxygen. right, a symbolic equation for this decomposition. So what is a decomposition reaction? There has to be only one reactant, and then there it could be more than one product, right? So HGO, the formula is already given, and you see the only products of this decomposition are mercury and oxygen. So they are giving you the products as well, right? So you just have to write their standard form. Mercury, it's a metal, so it will exist as Hg on its own, right? And like in its atomic state. And oxygen being a non-metal, it exists as a, a diatomic gas, so it will be O2, right? And now we have to balance this. So we have two oxygens on the right, so I'm going to put two here, so that makes two oxygens on the left. And now that we have two mercury atoms on the left, I'm going to put two here, and the equation is balanced. Okay, so the next question is aqueous hydrogen peroxide slowly forms water and oxygen at room temperature and pressure. So this reaction is catalyzed by manganese 4 oxide. The equation is shown. State the test for oxygen gas. So again, this is irrelevant. It's glowing splint relights, but let's go to the next one. Okay, yeah, this is the question which is related to rate of reaction. So a student investigates the rate of formation of oxygen gas when manganese 4 oxide is added to aqueous hydrogen peroxide. The volume of oxygen gas formed is measured at regular time intervals at room temperature and pressure. The results are plotted onto the graph in figure 4.1, and state how the graph in figure 4.1 shows the rate of reaction at time t2 is lower than the time t1, right? So here we can see that uh, you know uh, show how the graph in figure 4.1 shows the rate of a reaction at time t2. Yeah, so here you can see that the gradient is decreasing, right? So here, like, yeah, it has like lower gradient. So this is why we can say that that the rate of a reaction at time t2 is lower than the time t1, because at time t1 you can see that the curve is steeper. So this is a basic understanding. If a curve is steeper, the reaction is fast, and if the react if it is a lower gradient, so it means that um, you know uh, it is a slow reaction, right? So how will you answer this question? You will say that it has a lower gradient at T2. Okay, next question. Explain using collision theory why the rate of reaction at time T2 is lower than at as T2 is lower than at time T1, right? So here, again, this question has two marks. So again, it is related to the concentration of the reactants, because we just discussed in our previous while answering the previous question, this one, that as the time goes on, concentration of the reactants, they decrease, right? So you will say that the concentration of hydrogen peroxide particles decreases. So concentration of H2O2 particles decreases, and hence, you know, the frequency of collisions between particles decreases. Okay, so now on figure 4.1, sketch the graph obtained when the experiment is repeated using aqueous hydrogen peroxide at a higher temperature. All other conditions are remained conditions, they remain the same, right? So again, steeper curve which does not cross the original curve. Yeah, so you see the total volume of the oxygen gas produced must remain the same, and but it has to be steeper, right? So you can make it like this. It must start from zero, but you have now this reaction. It is occurring at a you know higher temperature, so you can see that the curve is steeper than this one, the previous experiment. All right, so now a student, question 12, a student investigates the progress of the reaction between dilute hydrochloric acid, HCl, and an excess of large pieces of marble calcium carbonate using the apparatus shown below. Okay, this is the gas fridge, right? I do it in the first question while answering the first question. So a graph of the volume of gas produced against time is shown in figure 5.2. Okay, they haven't asked any question yet, right? They are just introducing, like giving more and more data about the question. Okay, this is the question. State how the shape of the graph shows that the rate of reaction decreases as the reaction progresses. So again, you can see that here the gradient is decreasing, right? So we say that you can say that as the reaction progresses, we can see that the gradient decreases, right? So gradient decreases. So here you can see that steeper the curve, faster the reaction, and here the gradient is decreasing. So or less steep, so it means that a slower reaction. All right, so next one suggests why the rate of reaction decreases as the reaction progresses. The same thing, that the concentration of each of the reactant particles decreases, hence the frequency of collisions between the particles decreases, decreasing the rate of reaction. So it will also have to, okay, it has 1 mark. So all right, so you can say that that concentration of HCl is decreasing, right? So concentration of HCl is decreasing. So since it is 1 mark, so no need to write about the collisions theory and stuff. And because in this question, they specifically asked that explain using collision theory why the rate of reaction at time 2 is lower than the time at t1. So that's why we answered it more, elaborately. But here they're asking a simple question. So deduce the time which takes the reaction, or at which the reaction finishes. So you have to look from where the reaction on the curve, it becomes horizontal, complete, like a straight line, like a horizontal line, then it means that this is the, so it is around 200 seconds, right? So you can see here that if I draw, so this is the point where afterwards, from this point it is becoming straight. So yeah, all right, so 200 seconds. All right, next question is the experiment is repeated using the same mass of a smaller pieces. Again, surface area is being increased when it is being crushed. Marble is changed into crushed into smaller pieces. So all other conditions are kept the same. Draw a line on the grid to 5.2 to show the progress of reaction using the smaller pieces. So again, here we will have to draw the line which will look the same as the previous one, like this, right? Remember that in most of these questions where the previous reaction is ending, the total mass that of the product being produced in the previous under the previous conditions, so the mass, total volume produced or mass produced will remain the same, only it is produced more quickly. So you can see here that now, before when marble pieces were used, huge pieces, or it was not crushed into pieces, so it took 200 seconds to complete. But now with the crushed pieces with increased surface area, so the reaction is uh, you know uh, taking, like around 52 or 50, 5 or whatever, seconds in order to produce the same amount of oxygen that was being produced before in 200 seconds. So this is the difference, right? And this is what it is meant by increasing the rate of a chemical reaction. So now the next question is blah blah blah. Okay, you can pause it and read it yourself. Define the term activation energy. Yeah, so this is very simple. Again, the minimum energy that colliding particle must have to react, right? Or the minimum amount of energy, right? So minimum energy required uh, for a reaction, or for reacting particles, for reacting particles or colliding particles, right? So for colliding particles, minimum energy required for colliding particles uh, must have to react, right? So the minimum energy required for colliding particles, or the particles, must have in order to react. So the next question, explain why the rate of reaction increases when the temperature increases in terms of activation uh, energy and collision between the particles. So we have explained it already in the, here in this question. These two questions are very similar, exactly the same. You see, explain in terms of collision theory why increasing the temperature increases the rate of the reaction. So, but here it says, in terms of activation energy. So, and it has 3 marks. So we can say that, that the particles have more energy, so they will move faster. So or you can say that the kinetic energy increases. So I'm going to write particles have more energy and they move faster, right? And yeah, basically the same answer, right? Particles have more energy and they move faster, increasing the collision frequency and increasing the number of particles with uh, you know the activation energy, right? Okay, so I hope this is clear. We move on to the next one. So describe how the graph shows that the rate of this reaction decreases as this time increases. The same thing, because the less gradient. So we have answered this question before. So gradient decreases, and explain in terms of particles why the rate of reaction decreases as the time increases. Again, the same thing, because the concentration of particles decrease. So now you can see that the questions, they have started to repeat, and they are not asking anything new, anything different, the same thing again and again. So the student repeats the experiment using powdered magnesium carbonate instead of large pieces. All other conditions the same. On the grid, draw a line. Yeah, so same thing. This will be remain the same, and you just have to draw the curve, which will be steeper, right? More steeper, like this. And yeah, now the last question. Explain in terms of particles what happens to the rate of reaction. Again, it has the same answer. The particles have more energy, and they will collide more frequently, which will result in increased collision frequency. and increasing temperature also increases the number of particles with or greater than the activation energy, right? So there will be more effective collisions. So now I hope that this topic is 100% clear, and you will not have any problem answering any question on the exam related to this. But still, if you are confused or if you have any questions, you can contact me. You can leave your question in the comment below. If you wish to join my free once a month free lesson, you can join the community. And yeah, and Google form is also given in the description. You can contact me by filling the Google form. If you need one-on-one lessons, I will contact you. So I hope this is very clear, and this will be all for today from my side, and I'll see you in the next one. Take care. Goodbye.